Today we are going to be learning about a couple types of transformations, specifically translations and reflections. So transformation, when we talk about transformations, they're going to be any change in the position, shape, or size of a figure. Now on this topic, we're going to look at three specific types of transformations, and those types of transformations are translations, reflections, and rotations. Today we'll focus on translations and reflections, and then later we'll look at rotations. So all three of those types of transformations result in what are called congruent figures. Now congruent figures just means that objects have the same shape, they have the same size, so really all that happened is they shifted in one way or another. Maybe they were reflected, they were rotated, or they were moved. And they also result in what are called rigid motions. And when we use that word rigid motions, we mean that there could be a location change, so they change in location, but there's no size change. So the image just kind of moves somewhere, but it doesn't necessarily change in size, or it does not change in size. Now the first type of transformation that we're going to look at is what's called a translation. When we talk about translation, a translation is kind of like a slide. So every point of a figure moves the same distance and in the same direction. It has to move, every point has to move the same amount for it to be a rigid motion, for it to have no change in size. So when we look at our images here, we see that A prime, that's how we say that, B prime, C prime, is the image of, and actually we're going to put in here, A, B, C after a translation. So a lot of times when you have translations or transformations of any kind, usually they use regular letters on their first figure. So they'll use letters like A, B, and C. And then you'll see little tick marks on the other letters, and we call those we read that as prime. So we would read these points as A prime, B prime, C prime. And the reason why they use those tick marks is to show you that there's been one change. Now sometimes you'll also see where they'll say double prime, which would mean like if you had two tick marks, that's how you would read that, B double prime. And what that would mean is that you had two transformations that occurred. So the number of tick marks tells you the number of transformations. Now the next question, it says, what directions and distances was translated? And so if we look at our original image right here, or the original picture, and then we look at the image, the new picture that was created, we can see that our picture moved to the right, and then it also moved down. So we're going to say it moved right, and then it also moved down. Now if I want to figure out exactly how much it moved to the right, I can look at my values of A. So I can see that A went from an x value of -4, or an x value of -4 to an x value of -2. So that means that it moved 2 to the right. So right 2, and we can see that with our other values as well. B was an x value of -1, and now B prime is a value of 1. So it moved 2 to the right. Now looking at how much it moved down, we can see that it moved down, if we count 1 and then 2, 3. So it moved down 3 units. And we can see that with each of our points. We can see C went from being at 0 on the y-axis to now being all the way down to -3 on the y-axis. So it moved right 2 and down 3. Now let's look what happens to our points when we moved it. So A started out at -4, 1, and now A is at -2, -2. B was at -1, 3, and now B prime is at 1, 0. And then C was at 0, 0, and now C is going to be down at 2, -3. So what they're showing you right here is a way that we show a transformation that's occurred. So we show our letter in front of our ordered pair so that we know what point we're looking at, and then we draw an arrow and then the letter that corresponds with it. So A prime corresponds with A, and then we put our new ordered pair. So that's a notational thing that you'll see sometimes with transformations. Now, next thing that we're going to look at is how we translate figures. So far we just looked at what translation has occurred, but now we're going to pay attention to how to actually translate our figures. So notice with this example it says, translate 5 units left and 1 unit down. So we're going to start off by, like it says in step 1, graphing and plotting each of our points. So we see that A is at 1, 4. So at 1, 4 we're going to plot our point, and we're going to mark that as A. B is at negative 1, 2. So I'm going to plot B right here. And then C is at 3, negative 2. And then I want to connect my points to make a triangle. So now I have my triangle ABC. Now next thing, we have to translate each vertex 5 units left and 1 unit down, because it says 5 units left, 1 unit down. So we're going to take it vertex by vertex. Let's start with A. So we have to go 5 units left, 1, 2, 3, 4, 5, and then 1 unit down. So that's going to be A prime, our new A. B is at negative 1, 2, and then we're going to move 1, 2, 3, 4, 5 units left, 1 unit down, so it's going to go right here. So that's B prime. And then C, we go from 3, negative 2, we go left, 1, 2, 3, 4, 5, and then we go 1 unit down. So that's going to be my C prime. And then now that I have those 3 points, I'm ready to connect my points, just like we see in step 2. Now, an important thing that you should always look for when you make your translation is that the figure looks the same, because like we talked about before, the shapes should be the same, the size should be the same. So if it looks different, you know you made a mistake somewhere and you should go back and check your points. Now, the last thing we're going to do is just say what our values changed to. So A was at 1, 4, and now we can see that A was at negative 4, 3. B was at negative 1, 2, and now B is at negative 6, 1. And lastly, C was at 3, negative 2, and now C is at negative 2, negative 3. So take a minute to write that down. Now, something that you're going to notice when you do your translations is that your values really move. Like in your ordered pairs, they change as much as the translation. So if I move left, think about how on the x-axis that's decreasing your x value because you're moving left. And then if I move 1 unit down, that's decreasing my y value by 1. So notice that that happens with our ordered pairs. For moving 5 units left, my x value for A, 1. If I take away 5, it gives me negative 4. And then if I take away 1 from my y value, I get 3. Same thing for each of our ordered pairs. You'll notice that we end up taking away 5 from our x value for all of those, and then 1 away from the y value because we're moving 1 unit down. Now, if I were to move right and up for my translation, then I would be adding those numbers onto the ordered pairs. So that's another way to check and make sure that you got the right answer. So that's all that we're going to see for translations. Now we're going to move on and look at reflections. And you probably have heard that word reflections before, probably a little bit more than you've heard the word translations. And when we talk about a reflection is a flip. A figure is flipped over a line of reflection. The points will be an equal distance away from the line of reflection. So we see an example of this on the picture below. So it says P prime, Q prime, R prime, S prime is the image, so the new picture of PQRS after a reflection across the line x equals 1. So what they did is they drew in their line x equals 1 right here. That's any value where x has a value of 1, so that's why we have a vertical line there. And what we can see is that we had our original picture, PQRS, our original rectangle, and then notice that each of our points that we created in our image is an equal distance away from that line x equals 1. So for instance, P is over here at 4, 3, and it ended up being 3 units away from my line, and so is P prime. P prime is also 3 units away from the line. Q is 1 unit away from the line. Q prime is also 1 unit away from the line, and so on. We see that with each of our different values. Now, something else to notice is that across the line, our y value stayed the same because we had a vertical line of reflection. So the y values for each of my points didn't change because I really was just making it same distance away on the other side, and it wouldn't have shifted down if I want it to be symmetrical, if I want it to look like it being reflected. So we're going to look at an example of how we reflect an image. So our first step, just like when we did translations, is that we want to start off by plotting our points. And in this case, they're asking us to use the x-axis as the line of reflection. So I'm going to go ahead and plot my points. So I have A at 1, 2. So that's going to be A. B is at -2, 4. And then C is at -1, 1. And then we want to connect that to make a triangle. And then they're asking us to use the x-axis as the line of reflection, and so I would just make a dotted line over top of your x-axis, just like I'm doing. So darken it just a little bit so you can see it. So that's the line that you want to reflect it across. So think about that almost like a mirror. So you want it to be symmetrical on both sides. So now let's go ahead and fill out our steps. So we know if we look at A is 2 units away from the x-axis, and it's above the x-axis. And so when I draw A prime has to be 2 units away, but below. So it has to be 2 units away, but on the opposite side. Notice that my x value didn't change at all because I just want it to be straight across the x-axis. So A prime is going to be 2 units below the x-axis. Now we're going to do the same thing with our other 2 points. So notice that B is 1, 2, 3, 4 units above our x-axis, our line of reflection. And so B prime has to be 4 units, but below. So B prime is 4 units below the x-axis. So let's go ahead and mark B prime. 1, 2, 3, 4 units below. All right, and then our last one is C. Notice that C is 1 unit above the x-axis, and so that means that C prime has to be on the other side 1 unit below. So whatever side it's on, it's just going to end up flipping when we have a reflection. So now we want to connect A prime, B prime, C prime, and just like before when we had translations, we want to make sure that our picture looks kind of the same, that the 2 triangles look like they're the same size and the same shape. And in this case they are. They're reflected, so they're not facing the same direction, but each of our sides have exactly the same size, we have the same shape, we have the same angle measures in both of our triangles. Okay, and then we just want to mark our points. So A prime we can see is at 1, -2. B prime we said was at -2, -4. And C prime is at -1, -1. Now let's look back at how our ordered pairs were affected when we flipped it. So notice that for each of our ordered pairs that the x values stayed exactly the same. So the x values, 1, -2, and -1 for each of our points didn't change at all. But then when we look at our y values, 2, 4, and 1, notice that because we flipped it over the x-axis, that those numbers became their opposites. Now depending on your line of reflection, you might get something that looks a little bit different than that, but you will notice some similarities between A prime, B prime, C prime, and then A, B, and C. So at this point we are finished with our notes. If you didn't get a chance to fill in all your notes, make sure that you do that. And once you're finished filling everything out, you can get started on your homework.